This lesson is on identifying and combining like terms. So there are some vocabulary terms that you'll need to know in order to be successful. These will come up all of the time throughout this course. The first is a term. A term really could be a constant. It could be a value that has variables. This is an example of a term. This term happens to have an x as a variable. Or an x squared in this case. A constant would be if my term was, say, 8. So really it's just one value, one digit, whether it includes a variable or not. An algebraic expression is several terms that are being added or subtracted, so the sum and or difference. So this is an example of an algebraic expression. Notice this is not considered an algebraic equation because there's no equals anything. So that would make it an equation rather than an expression. So this is an expression because there's no equal sign. A coefficient is whatever number is in front of a variable. So in this first term, that's the 5 is a coefficient. In this term, the -3 is the coefficient. This term, 2 is not a coefficient because it's not being multiplied by a variable. 2 would just be considered a constant. And like terms, in order for two terms to be like, they need to be the same variable and the same degree. Degree meaning whatever the exponent is must be exactly the same, in which case we would add the coefficients or subtract them based on whatever operation they tell us to do. So first we're just going to identify like terms. These two terms are considered like terms because it's a t squared and a t squared. These two terms are not considered like terms because this is an a to the first and this is an a to the second, and so they're not like. These two terms are like terms. This is a constant of 4. This is a constant of 7 squared, which we could also write as 49. Those are regular numbers with no exponents or no variables, excuse me. My next one, I've got 24x squared y and 1x squared y. And again, x squared y is the same on both, so they are like terms. And my last example here, these are not like terms because this is d to the first and this is d to the second, which makes them not like terms. Go ahead and try this page on your own, then press play to see how you did. For the first, yes, these are like terms. They both have, oh, just kidding. Go ahead and try this page on your own, then press play to see how you did. My first one should be a no because a squared and b squared obviously are not like terms. My second example, a to the first b squared, a to the first b squared, so yes, these are like terms. My third example, this is p and this is np, so that addition of the n in there makes it so they are not like terms anymore. My next example, x squared y to the third, x squared y to the third. Yes, those are like terms. And my last example is no, because d does not have the same power. Let's take a look at combining like terms. When we combine like terms, again, we'll follow the order of operations and then we'll just combine things that are like. So in my first example, I would distribute this -3 so that I can get everything out of the parentheses. So -3 times 2x is -6x, and -3 times -8 is +24. And notice I'm just going to rewrite that -1. Now in terms of like terms, what I'm looking for is values, again, that are the same. So those three that I've just underlined in blue are like terms. This -6x does not combine with anything else. So that gives me -6x. And then 4 and plus 24 is 28, minus 1 is 27. For my second example, this first one, I'm distributing a negative, but if it makes it easier, distribute a -1, which would give me -6z and +10y. So remember, multiplying by just a -1 just changes the sign. For my second binomial here, I've got -4 times 3, so that's -12z, and -4 times +y is -4y, and then -8y. And then I'm going to combine like terms. And remember, we're going to write these in standard form, so I'm going to start with my y's. I've got a 10y and a -4y, which combines to +6y, and then -8y gives me a -2y. And then my other two are both z values. Negative 6 and negative 12 combine to negative 18z. Here are two for you to try on your own, so try them, then press play to see how you did. For my first example, I've got brackets and parentheses. So on the inside, I'm going to simplify as much as I can. So notice everything on the outside, nothing's happening to it, it just gets recopied. But on the inside, I have 2.2 times a squared, which is 2.2a squared. And then I have 2.2 times minus 6a, which is minus 13.2a. Now, before I distribute this 4, which would have to be my next step so that I can get all of this out of brackets, I can see that on the inside of the brackets, I've got a couple of like terms. So it's easier to combine them before I multiply than after, but either way would be fine. If I combine these two values together, actually I'm going to write my 2.2a squared first. I'm going to combine these two together to get minus 11.8a, and then still have my minus 5.1a squared on the outside. Now I'm going to distribute that 4. So 4 times 2.2a squared is 8.8a squared. 4 times 11.8a is minus 47.2a. I recopy that minus 5.1a squared. And now I'm going to combine these two values to get 3.7a squared. And this 47.2a is not a like term, and that's my final answer. For my last example, I'm going to be distributing fractions. Remember, fractions just mean multiply by the numerator, divide by the denominator. So I'm going to take this negative 1. Now remember, when we have a negative fraction, it's sometimes easier to think of it on the top. You certainly don't want to write it in both the numerator and denominator because a negative divided by a negative is a positive. So typically we'll just write it on that top number on the numerator. So negative 1 times 3 is negative 3, and then divided by 3, so I've multiplied by the numerator, divided by the denominator to get negative 1p. And then I do the same thing here. Negative 6 times negative 1 is positive 6, divided by 3 is positive 2. And then same thing is going to happen on my second expression. I've got 12 times negative 2, again, KFC. Negative 2 times 12 is negative 24, divided by 3 is negative 8p. And then negative 2 times 3 is negative 6, divided by 3 is negative 2. And then I'm going to combine like terms. So these two combine together to give me negative 9p, and positive 2 and negative 2 combine together to 0, and so negative 9p is my final answer.